Guy, have you heard about 5G? Guy, like, MTN is demoing the thing in Abuja right now.
You're lying.
Guy, go online on Twitter, you will see it. I'm not lying.
Guy, I'll kill you if you're lying, bro.
You can take my phone if I'm lying.
Now calm down. Let me get my laptop.
We must pay homage to him.
Bruh. What's poppin', everyone? Adama here. Now, I'm pretty sure you've heard about 3G, 4G, and 5G. I'm sure you've seen a lot of videos covering 5G. You've probably also seen articles covering 5G. And you're seeing all these awesome download speeds and the promised low latency that 5G is supposed to bring, and all the future use cases that it will also bring with VR and augmented reality. And then you're like, when is this going to come down to Nigeria? Well, I want to give you at least a little bit of an answer in this video. So let's get to it. But now, before we start, I want to address what 5G is, in case you don't know or your knowledge is just a bit low on that subject. Now, 5G is the 5th generation of cellular networks. Now, a cellular network is basically a radio network that is distributed over an area. Now, how our devices actually access these radio networks are through rats. Now, I don't mean the rats that always eat our stuff in our kitchens. I mean radio access technologies. So basically, these rats are what help us to connect to radio networks, use a radio network, switch between radio networks. And one example of a rat is Wi-Fi. So basically, it's your Wi-Fi rat that allows you to be able to find a Wi-Fi network in your area, connect to that Wi-Fi network. It's also what tells you whether that Wi-Fi network is fast, whether it's okay, whether it's slow. It's also what tells you the amount of people that are connected to it. So basically, your rats are very, very important. Now, how does this affect 5G? Your 5G modem or your 4G modem is actually a rat. So basically, if you remember, anytime you're on the 4G network and you're trying to make a call, your phone will normally downgrade the network from 4G to G on the SIM card that you're using to make that call. Now, this is because of your rats that are in work there. So now that we know a little bit about that, what's the essence of actually knowing about rats? Like, what's the use of knowing about these rats? Now, 4G operates under microwaves. In fact, most radio networks operate under microwaves. But then 5G operates under a type of microwave. It's not different from microwaves, but it's just, you can call it a subset of microwaves called millimeter waves. Now, millimeter waves are extremely high frequency waves that have wavelengths from 1 centimeter to 1 millimeter, hence the name millimeter waves. Now, they range from about 30 gigahertz to 300 gigahertz if you're going to talk about them in frequency format. Now, there isn't much of a difference between millimeter waves and microwaves. According to the Radio Frequency Engineering Group, it states that a microwave generally ranges from about 0.3 meters to about 3 millimeters, and then also has a frequency from 1 gigahertz all the way up to 100 gigahertz. It's not much of a difference if you look at it that way. And then you also see how millimeter waves are a part of microwaves, but then they're just a little bit off from microwaves. It's not a really big difference. Now, millimeter waves travel by line of sight. So what I mean by that is, if you're walking with someone and then you stop while the person keeps moving forward, while you're looking at the person, that point where the person goes and reaches and disappears entirely from your line of sight is basically the line of sight, or rather the limits of your eyesight. Now, millimeter waves travel in the same format. If something came in between you and the person, say a car drove past you and the person, or some bushes got in between you and the person, your line of sight is cut off, so the person disappears much faster than he's supposed to. Now, this is the case with 5G. Now, 5G, because they are millimeter waves and they have very, very high frequencies, their wavelength is very, very short, and it's the rule in physics. Now, millimeter waves can get obstructed by practically almost anything. They can get obstructed by rain. Gases in the atmosphere can suck them up. They can get disrupted by trees, by walls. Like, they are very, very, you can call them weak waves if you want, but I wouldn't really call them weak in my opinion. But then when you think about this, you now wonder, how will this actually affect us, or why is this of importance to us? Calm down, I'm getting to it. Now, there are bands that 5G operates under. 3 bands actually. Now, there are low bands, there are high bands, and there are mid bands. Now, the low bands are basically waves that are under 1 gigahertz. These ones can travel very, very far, and they are not obstructed by objects. They can move around objects, or they can move through objects. So basically, they are not affected by trees, by walls, by weather. And 5G can be propagated with these methods, but there is a catch. You won't be getting the very, very high download and upload speeds, as well as the very low latency that you're supposed to be getting out of this. You will still get speeds that are significantly faster than 4G, but it won't be to the standard of original 5G. But then, if you move higher up to the mid bands, these are waves that range from about 1 gigahertz to about 6 gigahertz. Now, these ones are shorter because, like I told you, the higher the frequency, the shorter the wavelength. These ones still travel quite far, but they have a limited range. And as the frequency is increasing, the speed is also increasing too. So these ones are now getting closer to the expected 5G speeds that you're supposed to be getting, as well as the latency, but you're not quite there yet. It's when you get to the high bands, these are basically waves above 6 gigahertz. Now, these are the ones where the millimeter waves actually reside. They get obstructed by obstacles pretty easily, and it's very, very annoying because practically almost anything can stop their propagation. Now, I've mentioned these 3 types of 5G, but if you wanted to conceptualize and try to make it easier for yourself, there are 2 other ways you can describe it. There are non-standalone 5G implementation methods and standalone 5G implementation methods. Now, non-standalone 5G implementation methods include the low bands and the mid bands, to where you're using 4G-like technology to propagate a 5G signal. Now, 4G signals are not millimeter waves. They can travel very far and they can still deliver very high speeds, which is true and very good, but they don't have the required speeds that 5G is supposed to bring to us. Like 5G is supposed to be giving us like 7.5 gigabits, 10 gigabits. Oh, and pay attention, I'm saying gigabits, not gigabytes. There's a difference. These non-standalone methods, as much as they are good, the only downside to them is the fact that they don't propagate 5G with the speeds that we ourselves are dreaming of. Now, the standalone 5G methods cover only the high bands, and these are the ones that bring the very high speeds, high uploads, low latency, and it's what we want from our 5G. But then, I've said all this. How does this affect the state of 5G in Nigeria? I'm getting to that, just relax. Now, since you have a general idea of what 5G is, let me now get into the measures that the different telecom manufacturers in Nigeria are actually taking to bring 5G to us, starting with MTN.
MTN, everywhere you go.
Now, on July 29th, 2018, MTN announced that they had, in 2017, signed a memorandum of understanding with Ericsson to collaborate on the rollout of 5G infrastructure in South Africa as a trial. They had also tested 5G use cases which they believed would have gotten them ready for 5G's commercial deployment before the year 2020. And then to further back up this claim, on November 25th, 2019, MTN demoed 5G in Nigeria, making Nigeria the first country in West Africa to actually have demoed 5G. That's all good and fine, but then how fast was it? Now, according to the demos, we were seeing 2,000 gigabits download and then about, say, 100 megabits upload. It's not that much. Now, you may already be guessing why it's not that much. I already said earlier that 5G is supposed to be getting about 7.5 gigabits, 10 gigabits and higher, but we're seeing 2,000 gigabits on MTN side. Now, that's because MTN is operating in the low bands. Now, I believe MTN was testing this on 100 megahertz and 300 megahertz, which is nowhere close to the mid bands at all. And as you can see, what I was saying, they are very fast, but they don't have the very, very high download and upload speeds that 5G is supposed to have. But before we move on from here, does anyone else notice that ping? Like, I saw this and I said, that can't be possible. From 5G, it shouldn't even be close to 100 at all. Now, this is a 4G speed test that I did on Glue. And look at that ping. Now, compare the two. Now, do you get my point? It's like, I don't get what happened. That number should be something around 10 to 5. Because 5G's latency is supposed to be at least 2 milliseconds. At most 2 milliseconds and at least 1 millisecond. So when I see that much ping on MTN's 5G, it's not very encouraging. But then this was a demo. I don't think anyone that came to that demo actually had a 5G phone to actually test this for themselves. So we can't say. Probably as time goes on, I think MTN is still going to keep the demo area for about 3 months. So probably people will buy 5G phones and come there to test, and we'll see how this actually rolls out. Now let me give you a general idea of what I mean about this ping. As a PUBG player, if your ping goes above 150, your game just starts to behave very stupidly. You could have gone at least a mile. This is just an example. You could have gone a mile, and then the next thing you see yourself back where you started because the server hasn't even taken the information that you have moved from this point to this point, because the latency is so high. So when your ping is increasing and getting higher and higher, your internet speeds, or rather the time between your app servers actually sending information back to your app, it will be a very, very long time. I don't know why MTN's demo was like this. Probably it's just a glitch from the application that they were using. I thoroughly hope that was the case. Well, moving away from MTN, let's move over to Glo. Now, Glo announced that they have taken extensive investment measures in network upgrades. They've already had 26 freight aircraft bringing network equipment for them, and that they will launch their 5G on the 700 megahertz frequency. Now, this is still a low band, and you may actually notice that MTN and Glo are probably the most popular network providers in Nigeria right now, and they're using the low bands. Why they are not moving into the mid bands, we don't understand. But I do have a theory. I'll get to that a little while later in the video. Just stick with me. Now, Airtel, on the other hand, announced that they are working with Ericsson to launch 5G. Now, as of now that I'm recording this video, I don't have any official confirmation that they have done any demos in Nigeria or anywhere at all. And I also don't know whether they are planning to deploy their 5G next year or in the year 2021 or 2022. Nine Mobile, on the other hand, we haven't heard anything at all from them, at least as of now I'm recording this video. Now, these are the four major service providers in Nigeria, but then there are others, and I didn't have time to actually go into them, but I'm pretty sure that all of them are working to get 5G to us as soon as possible, probably within 2020 and 2021. Now, as you already noticed, most of these carriers are giving us 5G on the low band spectrum. Even T-Mobile, one of the US's most popular service providers, launched its 5G on the 600 megahertz frequency. Their reason? The 600 megahertz frequency allows 5G to travel farther away and cover a larger area in the US than most of the other bands. Now, my theory in this is what these service providers are trying to do is they're trying to bring out 5G infrastructure and then slowly over time implement the original 5G methods, the standalone 5G methods that will then bring us to that time and age where latency practically does not exist between apps and their servers. It's my theory, it's not confirmed or anything, but from what I'm seeing and from the way every telecom company is acting, it's probably best to assume that this is what they are planning. Now, of course, there are a lot of standalone 5G implementations that have already been done. Verizon has already done this. MKBHD covered it in his video. And you could already see also that his 5G was also giving him about 2,000 gigabits of download and upload. And now you may just look at me and be like, Odema, you just said it's supposed to be 7.5 gigabits and above. Now, Snapdragon just recently announced their Snapdragon 865 chip, and they said that it's supposed to have download speeds of about 7.65 gigabits. 5G is supposed to have more than 10 gigabits per second, which is an alarming lot. So when you look at MKBHD's video and MTN's video, you see a similarity, and then you're now like, what is going on here? I can't really say for now, but then I do know that the problem could be coming from the chipset that is inside these phones. Now, we do know that a modem has a certain amount of speed that it can deliver at a time. So I'm going to guess that the 5G modem inside the phone that MKBHD was using didn't support those very extreme high speeds, because it was the Snapdragon 855 that was inside there, and Snapdragon 865 is out here. So probably we'll have to wait to see if someone does a speed test with a Snapdragon 865 powered phone and see if there's actually a difference. So now, there are other things that are actually standing in between service providers giving us full standalone 5G. And those things include money. Now, when I say money, I mean it in two ways. There are infrastructure problems, and there is also the phone problem. Now, when I mean infrastructure, I mean that it takes a lot of money to actually get a lot of 5G nodes, a lot of stand-alone 5G nodes in an area. Now, if you were in a corridor and it was a 5G and there was a 5G node there, you would have to have at least 5 or 4 5G nodes in that same corridor, so that as you're moving through the corridor, the different 5G nodes are sending 5G signals to your device, and you won't have to bounce from 5G to 4G consistently. That's one problem that 5G will face. Another problem that 5G will face in Nigeria is the cost of the phones that actually supports 5G. Now, as of right now, the phones I know that support 5G, there are actually very many, but the most popular will be the Samsung Galaxy S10 5G, the Samsung Galaxy Note 10 5G. These are probably the two most famous that a typical Nigerian person will know. These cost a lot, at least more than 150,000 in Naira, and that is a lot of money, and I don't see many people shelling out that much money for just 5G. It's not really that much of a big deal. 4G is already pretty fast, and some people are fine with that, and with rollout of 4G Plus also coming, you just don't see a big need to switch to a 5G phone just because of the download speeds. So what can be done about this? Now, Mediatek just recently released their Dimensity 1000 chip, and we already know that Mediatek makes the budget range chipsets that allow our phones to cost cheaper while still giving us top-end performance. So probably when phones start to roll out with this chipset, we'll start to see phones that come down below 100K that actually have 5G capabilities. Their download speeds may not be as high. I don't actually know how fast their download will be, but we'll have to wait and see for sure how things go. Now, another thing, this isn't actually a hindrance, but it's just something I should add. Now, one way that the telecom manufacturers can actually go about this is through CPEs. Now, what a CPE is it's a customer premises equipment. So basically, it's just basically a Wi-Fi hotspot that can use a 5G network. So think about it like this. Maybe you're in an office or in a company, and you place a single 5G node in one area and get a CPE and connect it to that 5G network. Then the CPE will now create a hotspot that will then give those who are connected to it 5G speeds. This is a good method that should be incorporated by most of the telecom manufacturers, because that will allow them to give 5G to people that don't have 5G phones. Now, the problem is you can't use it as a data network, but then I don't think anyone will have a problem connecting to a Wi-Fi network that is blazingly fast. So there's that. But then when you now think about the cost that CPEs may probably have you start to wonder what's the difference between getting a 5G phone and actually getting a CPE. But that's for the telecom manufacturers to do and for us to see how it turns out. Now, another hindrance is weather. Now, we already know that Nigeria has some pretty dynamic weather. It could be sunny 1 minute and the next minute it's raining or it's very, very windy. And there's also a lot of buildings in Nigeria. So how do telecom manufacturers go about dealing with this? Because I wouldn't want it to where I'm in a PUBG match on a 5G network and then because of a light shower of rain, my ping goes from an estimated 30 ms to about 150 ms, thereby ruining my entire match. I don't think I'd want that. So it would be very interesting to see how our telecom manufacturers go about dealing with this weather issue. And I think it's another thing that's holding them back from using standalone 5G methods. It would be safer for now to use non-standalone 5G methods and then actually slowly incorporate 5G, standalone 5G methods as time goes on. We'll just have to wait and see how things go. So that's basically the state of 5G in Nigeria right now. So after listening to all this, what do you think about 5G? Do you think Nigerian companies should wait till they have more efficient means of delivering 5G to the Nigerian people and delivering standalone 5G? Or do you think that they should use the non-standalone 5G methods first and actually move over to standalone 5G methods? Let me know in the comment sections below. Thanks for watching and I'll catch you next time. Peace. And do make sure you're subscribed, please. It took a lot of time to make this video, compiling facts and everything. So it would be a very, very great help to me if you subscribed.